brought the slides back up. This is the URL where you can actually, if you're on a computer, you can download the files from there, if you as well as the slides. So what I wanted to do is, of course, kind of give you some idea about how I processed it, and so basically I ended up writing 2 programs. But more importantly is I think it's the to share my thoughts and how I went about it. So the simulation seemed to run. I did I did something which is basically GNU plot, to just have a test run where the drunken dude runs on the grid, and I just count, basically use the grid just to count how often the dude was in the on that grid point. So if I do only a 1,000, so on a 3x3 grid, we get something like this here. That's basically, now of course we only have one cell that represents the center, and then we have the edges and the corners. If we increase that, I mean basically just to test how well our random number generator goes, we would get something, I use a larger grid, and then I get the edges here, and they're less frequently visited, the corners are even less, and then the middle field is fairly evenly visited. But it also, of course, it depends on the number of iterations. So if I only run this on 10,000, I still get quite some differences in here. But the numbers go down. And so if I have more iterations, so this one here has 10 million, that's it. So I assume that my random number stuff works okay. Let's actually run simulations and find out how long it takes. And so let's go straight to the result. And the odd thing is, and I haven't had enough time, so let me just run it. And I can, I think by default, I can set it up to run for 1,000 times. So let me do 10,000. It might take a little bit. Nope. So the simulation program runs, and I actually set it up. It produces an output. In my output files have the 2 input parameters that I have: the size of the grid and the number of iterations in there. And so if I run it at 10,000 iterations, then this is basically what it looks like. It gets me the iteration number. What does it get me here? It actually gives me the histogram. It gives me the days and the number of times. So I already basically produced it to create that histogram, so that it actually here, like 30 days, 54 times it has been 30 days. So what I get is the first column is the number of days, and then the second column is the frequency, and then the third column is just the divided by the total number of iterations. So I do that. So I get 3 columns here that I can then plot, and this is actually done again using GNU plot, and produce a plot, and this is how it looks like. So oddly enough, it looks like and that's really interesting, and maybe, worth to explore. Maybe, I get a really odd result here. I actually get sort of two Poisson distributions, and they're fairly good. If I increase the number of iterations, they get smoother and smoother. So we definitely have a good distribution with a peak, but what's interesting is that this almost looks like one distribution that goes with the odd days, which I think is the higher one, and then one with the even days. So it's like if you, it is sort of two separate types of outputs. If you take all the results from odd days and all the results from even days, you would actually get two very smooth distributions. And the peak is about the same. So I found this interesting, and the question now, of course, is like if this would be a scientific result, is that something to publish, or do I have an artifact here that is part of my programming error? And so it looks really cool. I think I did everything right, but I don't know if anybody has explored that, but it seems to be an odd and unexpected result. So as a scientist, if I have an unexpected result, of course I'm excited and I hope I can write a paper about it. But then as a computational scientist, there's always this daunting thing in the back of my head, like, well, where's the programming error? One little error could have been just producing these artificial results which have nothing to do with reality. And so I just encourage you, I don't know if you, how much it makes sense to go through it. This is the Drunken Dude is a shell script. What I do is like the different parts. You see, for example, if I do an animation, you see the line that says GCC, and it basically, what you see there with the -D, those are my macros that I define. And I just define those values in my shell script rather than in the C program. The shell script makes it easier to have input, and then I can use the same variables to produce, for example, here if you scroll down, I use that to also define the output name, and then also feed it right into GNU plot. So I basically, my script also produces a plot right away. That's not my program is the Sisyphus here. I have roughly to go through that. I create a lot of global variables because I'm lazy. This is really bad programming style, but again, I need to write a program that gives me an answer quickly, and after that I discard it. I mean, I keep it because, for the results, but it's not a software project. So I try to keep things simple, which for once, global variables. And one of the things in C is that global variables have to be, well, in C it's very static, so all like array allocations have to be static. So n is actually a constant parameter, it's not a variable, and that's why I define it as a macro. So if n is not defined outside my program with the compiler, it will be defined by 3, but this is what the preprocessor says. So I did a lot of stuff basically taking care of at the compile time. I have a couple of functions that put the output together, which ended up later. I created a function random choice, and that is basically to see where my new position is. So I broke it up. I don't know if it's the most elegant way to do it, but I broke it up that depending where my if, for example, if the dude is in a corner, there are only 2 choices where it can go, and if it's at the edges, and so I have all these different cases in here. There was a lot of cut and paste, and I have to make sure that I don't make a mistake in there. That's why also it's important to to simulate that. Other than that, is probably the most complicated part of that is the just to define like what is the proper movement, and I made that this function produces like a basically a delta x delta t and a delta y delta x, and then I just change the position from that. Then like basically I have these different parts, like for example running creating that random walk, or to run the simulation. I just again use conditional compilation. That way I can keep everything in one program, even if my program does different things, but then it allows me to keep those things together. If you're somewhat familiar with C, you should be able to read that, and hopefully it's not too complex. So that was kind of fun. What I didn't do answer the question because it asked for the mean day, and I haven't put that or the average day, I guess. And that would come out of 1,000 simulations. But I give you instead a distribution, which I thought was much more interesting.